Hello, in this video I am going to explain about single-phase half-bridge inverter with MATLAB simulation. Before starting with the simulation, let me give you a general overview of inverter. What exactly is an inverter? As the name suggests, it is responsible to invert or keep on changing the polarity of output signal by using a steady DC input. Inverters can be classified as single-phase inverters or three-phase inverters. In single-phase inverters, we have half-bridge inverters and full-bridge inverters. We also have PWM inverters, which are further classified as single PWM, which has one pulse per half cycle, and multiple PWM, which has multiple pulses per half cycle. We also have sinusoidal inverters. May have observed humming sound coming from the ceiling fan when line voltage goes down and the supply is being given from inverters at home. This happens because the inverters use PWM technique. Hence, the noise is created as exact sine wave is not obtained as the average of this kind of inverters. However, to reduce the noise, multiple level PWM inverters are used. The three-phase inverters are classified based upon the angle of conduction, that is 180-degree conduction and 120-degree conduction. However, we will focus currently on single-phase half-bridge inverter. This is the circuit diagram of the inverter. This is an IGBT which will be used as a switch. It is preferred to use IGBT or power MOSFET as these support higher switching frequency. This output can be also achieved by using thyristor. This is the network that divides Vs in equal voltages, that is Vs by 2. Now let's look at the working of this. Either of the IGBTs should be on at a time. So let's give a pulse to Q1 and let Q2 be off. Thus Q1 turns on, the current flows through Q1 to load. Here the voltage polarity is same as that of output polarity. In the next part, Q1 is turned off and the supply is given to Q2. In this case, the current will flow in the opposite direction as compared to the polarity of output. This is how the waveform will be at the output. It is quite clear that a steady DC voltage is getting converted into an alternating current. This is how an inverter works basically. Now let us look at the simulation of this in Simulink. So for this we require a SimScape and Power GUI. Open your MATLAB software. Simply type here Simulink or click on Simulink icon. Once Simulink start page pops out, click on blank model. So create a model. So it will take some time for creating that model. Press Ctrl Shift L to open the library window. We need some components, so let us bring all those in the window. Let's take IGBT. So open the library window by pressing Ctrl Shift L. Type the name of the component that you want. That is, now we want IGBT. So drag the IGBT and place it in the window. We will also need the RLC element. So we will also place RLC. So for now we are constructing half wave bridge using R load. So we will take R load. We will also need a scope. So I have dragged and placed a scope. We will also need a voltage measurement and current measurement. Now let's take current measurement. And finally, voltage source. So now double click on DC source symbol. Now we need to change the voltage level to say 10. Here you can enter any values. Now for make the number of channels to 4. Also place go to and from. Here you can change the name and copy and paste all the elements as we require multiple of these. So for instance, I have created a circuit of half bridge inverter. Recheck the properties. Now double click on either of the pulse generator. So set the frequency. Make sure that other one is opposite so that both IGBTs won't turn on together. I have made the connections accordingly. Make sure that you have selected all the components and made the connections properly. So we will run the circuit now. It will take some time to initialize all things. So this is the output from the first scope. We need to observe the voltage across the R load. If the supply is not sine wave, then the duty cycle can be changeable. If we add a DC offset to the sine wave, then the duty cycle is also changeable. Now you would want to do these things. That's difficult answer. Half-wave bridge inverters are poor efficiency and have high ripple. So to change the duty cycle, you can click on any of the pulse generator and just change that period. Now if I type 2 and save the changes, half-wave bridge inverters are less expensive and also very simple and widely used in industrial applications for industrial DC drives. Phase-controlled inverter applications include paper mills, textile mills using DC motor drives, and DC motor control in steel mills. Further, application also includes AC-fed traction system using DC traction motor, electrometallurgical and electrochemical processes, reactor controls, magnet power supplies, portable hand instrument drives, flexible speed industrial drives, battery chargers, high voltage DC transmission, and UPS, that is uninterruptible power supply. So today we learned what are inverters, what are types of inverters, that is single phase and three phase, brief view of types of single-phase inverters and three-phase inverters. In single-phase inverters, we saw the working principles and the output waveforms and also the circuit diagrams. We learned the simulation through MATLAB. We constructed a circuit diagram and saw the output and also learned few applications of single-phase half-bridge inverter. Thank you.